In the previous video, we saw how to go from your x-score to computing the z-score and how to go from the z-score to computing the area. Now in this case, we want to flip the switch and no more talk of the area, but talk of the probability. So if we want to look for the probability or the likelihood of something, how do we proceed? Now, we are under the assumption that your x-score is normally distributed, or it has this shape. And most variables in nature, for example, the height, the weight, the age, generally you have such a distribution. Now, so when you see mu, you are talking of the population mean, and when you see sigma, you are talking of the population standard deviation. So let's say you have an x-score, or the height of students. If this is the population mean and this is the population standard deviation, you can compute the z-score for a given value. So in this case, we are using the value of 600. However, before we compute anything, the assumption is that the x distribution looks like a bell shape. Okay, let's move on. So if you want to compute the probability of x being less than 600, now just so you know, whenever we write this, we will either be computing the probability of x less than a certain number, x greater than a certain number, or x being in between two numbers. So when we say x less than a certain number, it means we are looking for the area to the left. X greater than a certain number, it means we are looking for the area to the right. X in between two numbers, it means we are looking for the area in between. That's all. So in this case, we want to look for the area or the probability to the left of 600. You've been given the mean and standard deviation. All you need to do is to first convert your x to z-score, and from your z-score, you compute the area to the left. So in this case, you plug it in this formula, and once you have that, so you are moving from x to the z plane, and once you have that, you can immediately go and do your computation, and that will give you your probability. So let's take this example. So in this case, we are saying that the average, you've been given the average as 1.5. You've been given the standard deviation as 0.25. And you are being told that you should compute the value for less than 1. Okay? Less than 1. Now, the assumption, as we said, is that it's normally distributed. If it's not normally distributed, it will not work. So we always assume that it's normally distributed, or we verify before we do the calculation. But you don't have to do that, because all questions I will give will be the ones which are normally distributed. Okay, let's do it. So less than means to the left. So what happens is that we need to compute the z-score and then take a look at the probability. When we compute the z-score, given the values provided, the z-score is -2. And when you go to your table, you will find that the area to the left is 0.0225. In other words, the probability, you just multiply by 100 and you have 0.2, and you have 2. Basically 2.28%. Let's move on to the next example. Here you've been given an average of 45, standard deviation of 12, and you are asked to compute the area between 24 and 54. So you first convert this to the z-score. The z-score, you look for the probability or the area to the left of 24, the area to the left of 54, and then you deduct the smaller area from the bigger one. So let's do it. So first we will convert 24 and 54 to their z-score, given the mean and standard deviation. So there we go. We have these two z-scores. Once we have these two z-scores, we have to look for the area to the left of the first one, the area to the left of the second one, and we deduct the smaller one from the bigger one. So you go to your table to obtain that, and then there you go. It's important you do every step. It's important you go to your table and look for it. Then you will have fun doing this. It will not be confusing. Let's take another example. Here we want to look for the probability that someone will be more than 39 minutes. So we are looking for the area to the right. You've been provided the mean and standard deviation. So you first convert this to the z-score. Then you look for the probability to the left of that z-score. Then you do 1 minus that probability. So here we go. You have to convert this to the z-score. Once you convert it to the z-score, you have to look for the area to the left of negative 0.5. And once you look for that, you do 1 minus it, and it's going to give you the value to the right. So this is the value to the left provided by your table. When you do 1 minus that value, you now get the probability of the value to the right multiplied by 100, then you have 69%. Okay, let's take this one. It says, if 200 shoppers enter the store, how many shoppers would you expect to be in the store more than 39 minutes? Note, it's the same question we are talking about, okay? This is just a continuation. So you want to look for if you've been given 39. So what do? Is that you simply multiply 200 by that value. Remember, we've already computed this as the value, as the probability of having a shopper in the store for more than that time. So now if you are looking at 200 shoppers, it means you are likely to have, that's the probability that they will be there for more than that time. You just multiply. And that's it for this part. In the next video, we will look at how to look for values.